The next part, we look at how can you actually solve a system of equations using matrices. Well, first of all, we would set up a system of matrix equations. So what this tells us is that first we want to set up a matrix A. The matrix A is going to have to deal with the coefficients of our variables. So that would be the 2, 2, negative 3, and 2 here. So let's go ahead and make our matrix A of the coefficients, which would be 2, negative 3, 2, and 2. Then it says to have a matrix X. That's going to be our matrix of our two variables, which happen to be X's and Y's. So that matrix will just be a straightforward matrix with just our two variables, X and Y. Now what you'll notice is if you wanted to double check that this works out is remember when you multiply the row times the column, and that will get the first part of your equation, which is 2 times X is 2X, and negative 3 times Y gets you negative 3Y. That's the first part of your first equation. And if you were to look at the second part, it works the same way. We've got a 2 and a 2, and the X and Y, so it'd be 2 times the X first, and then 2 times the Y. That gets you your 2X plus 2Y here. Now, equals, well, according to the formula above, it should equal whatever the constants are on the other side of the equation, which in this case is a 10 and a 5. So that's your matrix B. So we'll go ahead and put that on the other side, just our regular constants, what things should equal, which is a 10 and a 5. Now, what does this tell you need to do to solve for the X and Y, the matrix that has X and Y? Well, it says to solve for the matrix that has X and Y in it, that's our matrix X, you take the inverse of which matrix? Of the first matrix A. Be careful, it needs to go in front of your matrix B. Remember, with matrix multiplication, you can't just swap the order around because it won't be the same. So you need to make sure that whichever matrix is over here on the left is when you take its inverse and move it over to the other side, it needs to also be first on the left on the other side. So what this will mean is to solve this, we're going to have that our X and our Y will be over here now, but we're going to move this matrix over to the other side by putting its inverse right in front. So we will say that this thing equals, and we will put the inverse matrix right in front of that matrix B, which has got the 10 and the 5. So I need to put the inverse in here first, and then I can go ahead and multiply it times your matrix B, and then that will give me what X and Y are. So how do I find the inverse of this matrix over here? Well, remember, for a 2 by 2, you have to find its determinant first. So let's find what its determinant is. Remember, the determinant starts by finding what? You do the cross multiplication, 2 times 2, which is 4, minus doing the other cross product, which is, let's see, 2 times negative 3, which is negative 6. So we've got 4 minus a negative 6, which will turn into a plus 6, which means that the determinant is actually 10. So how do you find the inverse? Remember, you do 1 over your determinant, so 1 over 10. Times, we have to slightly modify that matrix there. Remember, we swap the A and the D. Well, luckily, A and D are both 2, so if you swap them, it's still 2 and 2. What's going to be different is the B and the C. They're going to stay where they are. We're just going to switch the signs. So the 3 will go from being negative to positive, and the 2 will go from being positive to negative. Now, be careful. I have to multiply this 1/10 out to everything inside that matrix in order to get my inverse. So let's go ahead and do that, and we'll go ahead and input it in here because it will be our inverse. Well, the 1/10 times the 2 here will get us 2/10, which is 1/5. The 1/10 times the 3 here will get us 3/10. The 1/10 times the -2 will get us -2/10, but that reduces to -1/5. And the 2 times the 1/10 gets us 2/10, which is, again, reduces to 1/5. So that's our inverse matrix. Now we got to take that inverse matrix and multiply it times the constant matrix, and that will give us what our x and our y is. Well, how do we multiply those two matrices? Well, first row, first column. Let's go ahead and do the math. Again, if we had a 2 by 2 times this is a 2 by 1, we know that the product will end up being whatever the outside is, which is a 2 by 1. So my answer should be a 2 by 1 matrix. So let's do that first row with that first column and see what we get. Well, you'll do the 1/5 times we'll do the 1/5 times the 10 first, which is 2. So we'll get 2 for that. Added to, well, now I have to do the 3/10 times the 5. Well, that will give me what? 15 over 10. Well, if I want to add those two, then I need a common denominator. Well, 2 is, if I want a common denominator of 10, is 20 over 10. Added to your 15 over 10 will actually get us 35 over 10. Be careful, that can be reduced. They're both divisible by 5. So it reduces to 7. And dividing the bottom by a 5 also gets you a 2. I have to do the same thing all over again with the second row, and still I've only got one column, so second row and first column. So let's multiply and add. Well, we've got the -1/5 times the 10, which will give us -2, added to. The 1/5 times the 5 will give us a 1. Well, -2 added to 1 just gives us a -1. So the second entry is just a -1. What does this mean? Well, this was my XY matrix I should be getting, which means if I read straight across the top, it means that X is 7/2. So X equals 7/2. And reading straight across the bottom, the Y is -1. So Y is equal to -1. So that gives me yet another way to solve a system of equations. That my X is 7/2 and my Y is equal to -1.